Okay, so we're going to look at a few commonly missed problems on the last test. This first problem, an urn contains 9 blue marbles and 7 yellow marbles. So you have this urn that has 9 blue marbles, 7 yellow marbles. That's a total of 16 marbles in the whole thing. Then the next part says a marble is drawn and dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were yellow. If another marble is drawn, what is the probability that it will be blue? Okay? The sentence that came before that one about marble being drawn out and dropped back in and what colors they were, that has no influence whatsoever on this question. I mean, it doesn't matter. They were taken out and they were put right back in again. All right? So right now, there's an urn with 9 blue marbles and 7 yellow marbles. All we want to know is, if you draw a marble now, what is the probability that it will be blue? Okay? So that second sentence has no effect whatsoever on the question. You took them out, you put them back in, everything's back to the way it was. So the likelihood that you're going to draw a blue is going to be 9. There are 9 blue marbles over 16. There's a total of 16 marbles in there. That's the probability. Probability is the number of possible outcomes that are the outcome you're looking for, and then in the denominator, it's just the total possible number of outcomes of all kinds. All right. Number 2, a fair coin is tossed 3 times. What's the probability that the first toss comes up heads and the next 2 come up tails? All right, well, the probability of flipping a coin and getting heads is 1/2. 1 out of 2. All right, there's 1 head, and there are 2 possible choices, the 2 possible things that could come up. All right, so each time you flip it, the probability of getting a head is 1/2. The probability of getting a tail is 1/2. All right, so they're asking you, what is the probability that the first toss is heads and the next 2 are tails? So you can multiply the 3 probabilities each one of those flips. So the probability that comes up heads is 1/2. The probability that it comes up tails on the second try is also 1/2. The probability that it comes up tails on the last flip is also 1/2. So the probability that if you flip it 3 times, you'll get heads, tails, tails is 1/8. All right, a single die is rolled 2 times. What is the probability that the next roll will produce a number less than 4? Again, it doesn't matter that you rolled it 2 times before. You haven't changed the die. You haven't done anything to it. All they want to know is, what is the probability that the next roll will be a number less than 4? So the first 2 rolls have nothing to do with this question, because all they're asking you is, what's the probability that the next roll is going to be less than 4? All right, so on the die, 3 of the numbers are less than 4. 1, 2, and 3. So there are 3 possibilities that are less than 4, and there are a total number of 6 possible things you could roll. So the probability of rolling a number less than 4 is 1/2. Okay, when you're finding weighted average, like on number 4, all right, let's look at number 4. It says Mr. Hooper's test scores were 70, 80, 60, and 90. What is the weighted average if the tests were weighted 1, 2, 5, and 3, respectively? All right, so when you have a weighted average, what you're saying is, I want to pretend that this test counts this many times, as if you took it this many times. So the first test just counts as 1 test. The second test counts as 2 tests. The third test counts as 5 tests. And the fourth test counts as 3 tests. That's kind of what it's saying. It's as if you were going to add 70 plus 80 plus 80 plus 60 plus 60 plus 60 plus 60 plus 60 plus 90 plus 90 plus 90. It's as if each test happens that many times. That grade counts that many times. All right? So if you were to add all those up, you would divide by the total number of tests as if they happened that many times, all right? But to do it without writing everything out so many times, to do the weighted average, we can just write, so weighted average 70, that one counts once. The 80 counts twice, so I'm going to multiply it by 2. This 60 counts 5 times, so I'm going to multiply it by 5. And then the 90 counts 3 times, so I'm going to multiply it by 3. And then you don't divide by 4, because remember, you're pretending that these tests happened as many times as they are weighted. So you're going to divide by 1 plus 2 plus 5 plus 3. So there's 1 70, 2 80s, 5 60s, and 3 90s. So you would multiply all that out and divide it, and that would be the weighted average. I think it was something like 72%. Okay, make sure that when you are factoring, the first thing you do is to factor out the least, or the greatest common factor. So on number 10, you can see that each term has a factor of x. So you can start by factoring that out. And you're left with x squared plus 12x plus 32. All right, now you can factor this quadratic. But don't lose the x. It doesn't disappear. It's still there. So don't just not write it. It's there. All right, so you can now factor the quadratic that's in the parentheses, and you're looking for two numbers that multiply together to give you 32 and add up to 12. And that is, of course, 8. And it's all positive. Oops, sorry, 8 and 4. Oops, 8 times 4 is 32, and 8 plus 4 is 12, so that's 4. All right, same situation with number 11. You factor out the 4 first. 4 times x squared plus x minus 30. And then you factor the quadratic, but the 4 doesn't go away. It's still there. All right, so x, and you're looking for two numbers that their product will be negative 30 and their sum will be 1, because it's 1x for that middle term. So that's going to be plus 6 minus 5, because you want the two numbers that you want their product to be negative 30 and you want their sum to be positive 1. All right, and then on number 12, if you look here, you've got a common factor of x plus y for every term. So you factor that out first, and then you see what you have left. You have a squared plus 10a plus 21. Now you have to factor that quadratic, but don't lose your x plus y. It's still sitting there. All right, so for a squared plus 10a plus 21, you've got an a here. You're looking for two numbers that their product is 21 and they add up to 10, and that's going to be 7 and 3. All right, number 13, you're supposed to write a conjunction that describes this graph. All right, first of all, in a conjunction, remember, both of the inequality signs should point in the same direction. There shouldn't be one pointing one way and one pointing another way. So be careful how you write this. All right, so the conjunction you want to write is you want it to somehow explain that x, all the numbers on this graph, are between negative 2 and 3, not including negative 2. All right, so the x goes in the middle. All right, and what you're actually going to say is that negative 2 is less than x, so that means that x is greater than negative 2, and x is less than or equal to 3. So that's where x is between negative 2 and 3, including 3. And then the domain on this graph is the real numbers. If it was the integers, it would have dots instead of a solid line like that. Okay, I'm seeing a lot of problems on this type of problem, number 14. I showed you two ways to do these problems. So I think I will go ahead and show you how to do this both ways. One way you can do it is to look at the little fractions, 4 over y, y over b, and 2b. And look at their denominators, y, b, b. And find the least common denominator for those three denominators, which would be yb. The two factors involved here are y and b. So the least common denominator for those three fractions is going to be yb. All right? So now what I'm going to do is I'm going to multiply the top by yb and the bottom by yb of the big fraction, okay? So I'm multiplying the whole big fraction by yb over yb, which is 1. And so it doesn't change the value of the fraction. All right, and so to do that, in the numerator, I'm going to have to use the distributive property. I'm going to have to multiply yb times 4 over y. When I do that, the y's will cancel, and I'll get 4b. Next, I'm going to have to multiply yb by that second fraction, by y over b. When I do that, the b's will cancel, and I'll get y squared. In the denominator, I'm multiplying 2 over b times yb, and therefore the b's cancel, and I end up with 2y. All right, so that is one way to do this problem. It's the one-step way to do it, but many people find this confusing. So unless this just totally makes sense to you, do not do it this way. But I want to include that for the people for whom it does make sense. All right, so let's look at the other way to do this. The other way to do it is to get a common denominator in the numerator and add those two fractions. So in the numerator here, we have this sum of two fractions. What we want to do is get a common denominator and add those fractions together so that they are just one fraction. So doing it off to the side here, I'm going to add 4 over y plus y over b. Now again, for these two fractions, the common denominator is yb. All right, so you've got yb, yb. You're just going to add these two fractions together. Common denominator is yb because those are the two factors involved. All right, to get the first fraction to have a denominator of yb, you're going to have to multiply it by b over b. See, yb. All right, so the numerator will become 4b. The second fraction has a denominator of b, so you want to also get it to have a denominator of yb, so you multiply it by y over y. That will give you y squared over yb. And so that, I got my common denominator, and I'm going to add those two fractions, 4b plus y squared over yb. All right, so that's the numerator of this fraction we started with. All right, I just did that off to the side. So I got a common denominator for these two fractions that I'm adding together in that numerator of the big fraction. And I'm going to write what I got. I got 4b plus y squared over yb. So that's what I got for the numerator. And then the denominator is still 2 over b. All right, so now I have this fraction divided by this fraction. And when you divide fractions, you multiply by the reciprocal. So I'm going to have 4b plus y squared over yb times the reciprocal of 2 over b, so b over 2. I'm going to have to erase that so that I can have room. Let me see if I can write that smaller. So it was 4b plus y squared over yb over 2 over b. All right, so I'm just rewriting that as 4b plus y squared over yb times the reciprocal of 2 over b, which is b over 2. All right, and when I do that, since this is multiplication, I'm multiplying two things together, I can cancel that b on the top and the bottom. So I just end up with 4b plus y squared over 2y. All right, so whichever way you want to do those problems, figure out which way you can do it so that you get the right answer. Make sure that you know how to simplify a complex fraction. Remember, a complex fraction is a fraction that has fractions in it. Okay, so this next problem, number 15, is also a complex fraction problem because even though it doesn't look like it, there are fractions in the numerator and there are fractions in the denominator of this fraction. Because you have x to the negative 1, which is 1 over x. You have x to the negative 3, which is 1 over x cubed. You have x to the negative 1, which is 1 over x. All right, so that's the first thing you have to do. The first thing you have to do here is substitute in all those fractions for all those things that have negative exponents. And the reason you can't just start moving that x to the negative 1 down and that x to the negative 3 down and all that is because this is not all multiplication. You have addition going on here. All right, that means you can't just start moving things up and down. All right, so the first thing you have to do is just substitute for all these negative exponents, the equivalent fraction that has the positive exponent. All right, so 3x to the negative 1 is 3 times 1 over x to the positive 1. And then x to the negative 3 is y over x to the positive 3. Or it's y times 1 over x cubed, which is y over x cubed. And then in the denominator, you've got x to the negative 1 times y squared, which is going to be 1 over x times y squared, which is just y squared over x. All right, and I could have just written that 3 times 1 over x as 3 over x, because that's what it is. All right, so that's what you have to do first before you can even start moving anything around. You've got to deal with those negative exponents. All right, now you treat this problem just like the one we did before. You have to find a common denominator on the top, and then you will rewrite this whole fraction as a division problem where you're multiplying by the reciprocal. So the first thing you do is take that numerator and get a common denominator and add them together. So 3 over x plus y over x cubed. The common denominator here is not x to the 4th. All right, the common denominator, you want the least common denominator, the smallest thing it can be where it has all the factors you need. All right, so x cubed is the common denominator because x divides evenly into x cubed and x cubed divides evenly into x cubed. That's all the factors you need, right? Because the first fraction has a denominator of x, so it has one factor of x. The second fraction has a denominator of x cubed. That has 3 factors of x, 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 x. All right, so x cubed has all the factors necessary for the common denominator. All right, because, for example, when you want to rewrite that first fraction with the denominator of x cubed, you can just multiply the top and the bottom of it by x squared. So you're multiplying it by x squared over x squared. That will give you a denominator of x cubed and a numerator of 3x squared. And then y over x cubed is already over x cubed. You don't need to do anything to it. So you've got the common denominator now. You just add the 2 fractions together. And this is what you have. Now, that is what we're going to put in for the numerator of this fraction. We just added those 2 fractions together. All right, so when I add those 2 fractions in the numerator together, I've got 3x squared plus y over x cubed. That's what I just did. And then the denominator is y squared over x. It's only one fraction, so we don't have to do anything else to it. And now we simply change that division problem to a multiplication problem. We multiply by the reciprocal. So numerator times reciprocal of the denominator. So y squared over x becomes x over y squared. All right, and remember, you're multiplying that whole thing by this whole thing. And so one of these x's is going to cancel. You can cancel that x with one of those x's. So you'll have just x squared there left on the bottom. So your final answer, it'll be totally reduced, is 3x squared plus y over x squared y squared.